My name is Hossein Gezala, and I'm pleased to be presenting the next generation carbon capture technology based on carbonate fuel cells developed by FuelCell Energy for simultaneous carbon capture, power generation, and hydrogen production. Founded in 1969, FuelCell Energy has developed environmentally responsible products for distributed power generation, distributed hydrogen production, and carbon capture solutions, which are trademarked SureSource based on carbonate fuel cell technology platform. Let's look at how SureSource cell works. As shown in the figure in the left, each SureSource cell has two compartments similar to a plate fin heat exchanger. One of the compartments is the cathode, where the CO2-bearing flue gas is fed. In the cathode, one molecule of carbon dioxide reacts with half molecule of oxygen and absorbing 2 electrons to produce a carbonate ion. The negatively charged carbonate ion migrates from the positive cathode to the negative anode, which is the second compartment in the SureSource cell. The carbonate ion reacts with hydrogen in the anode, producing 1 molecule of carbon dioxide and 1 molecule of steam. This oxidation reaction process releases 2 electrons that flow in external circuit to produce electric power. Hydrogen is produced by internal reforming of fuels such as natural gas within the anode compartment, where specialized reforming catalysts are placed. The configuration of a single SureSource cell is shown in the bottom of the slide. As an overall process, SureSource cell transfers carbon dioxide from cathode side to the anode side, that is the fuel side. It accomplishes this carbon dioxide transfer with complete selectivity towards carbon dioxide as compared to nitrogen in the flue gas. The net result is a concentrated stream of CO2 exiting the anode compartment. Therefore, the SureSource cell can be used as a carbon capture plant to separate CO2 from flue gas of other plants and simultaneously produce power. This co-production of power provides revenue stream to improve economics of the power plant. Additional benefits include flue gas NOx destruction and excess water production as a result of the chemistry within the fuel cell. Efficient conversion of methane fuel to hydrogen in SureSource provides capability for hydrogen co-production and the opportunity for hydrogen export. SureSource fuel cells are manufactured in FuelCell Energy facilities, from single planar cells to stacks of 400 cells to a finished 1.4 megawatt power module ready to be transported to the customer site. Let's look at the operation of the entire SureSource carbon capture system. A simple process block flow diagram of the carbon capture system is shown in this slide. The CO2-rich flue gas from a power plant or industrial site is shown in the green color at the bottom of the diagram. This flue gas is first heated using the waste heat from the system. The heated flue gas, shown in the orange color, enters the SureSource cathode, where up to 90% of its CO2 is stripped off, forming carbonate ions. The remaining CO2 depleted flue gas flows to a heat recovery system where its sensible heat energy is used to heat up the fuel and vaporize water to make fuel-steam mixture with a carbon-to-steam ratio of 2 for natural gas-based systems. The CO2 depleted gas is finally exhausted from the system. The humidified fuel, shown in dark blue color, enters the SureSource anode, where it is internally reformed to form hydrogen. The produced hydrogen converts the carbonate ions to carbon dioxide. The overall electrochemical reaction as mentioned before, produces water and makes the stream rich in CO2 and some remaining hydrogen. The overall process also makes electricity that is exported to the grid. The outlet of anode exhaust is first cooled down to remove the water content of the CO2-rich stream, and then is compressed and chilled in a chiller to separate pure liquid CO2 as the carbon which is captured. The remainder fuel stream is highly concentrated in hydrogen. Now, there are two options for using the hydrogen produced from the carbon capture system. One is to recycle the hydrogen back to the system to increase the overall efficiency of electric power generation capability of the SureSource carbon capture. The second alternative is hydrogen to X, using a small final PSA system to strip off pure hydrogen from hydrogen CO2 mixture. So, as discussed, the overall SureSource carbon capture system is capable of capturing in excess of 90% of CO2 from the subject flue gas while producing power simultaneously. Plus, it provides an option to produce pure hydrogen for export. One other attractive feature of the system is being water self-sufficient. The plant actually produces excess processed water that can be beneficial to the power plant or the industrial site. The economic benefit of SureSource capture technology is due to the revenue from additional power produced by the fuel cell, offsetting the operating cost of the system, resulting in a low cost of carbon capture. I would like to thank you for your attention to my presentation. For further inquiries about SureSource carbon capture systems, please contact me through my email address hkazal@fce.com.